Okay, you ready? Okay, 6-1. We are talking about confidence intervals when the standard deviation is known. Okay, so point estimate. A single value estimate for a population parameter. The most unbiased of these is the mean. So when you find the population mean and you find the sample mean. Little X with a line over it, sample mean. Okay, so that's the most unbiased point of estimate. So for instance, a researcher is collecting data about college athletic conferences and its student athlete. A random sample of 40 students are selected and their number of hours spent on required athletics is recorded in that chart. Find a point estimate for the population mean and the mean numbers of hours spent on the required athletic activities by all students in the conference. So all we're doing is finding the mean of the sample. Okay, so how would I find the mean of that sample? Petey, how would you find the mean? Add them all up and divide by 40, the numbers there, right? So, I mean, it's fine to me. So when they say point estimate, they're going to ask you to find the point estimate of the mean, population mean. So you're going to find the sample mean. That's it. Okay? So you're going to add them all up, divide by 40. I know you know how to find the mean. I'm not going to have you get your calculators out for that. Okay? Adding all, divide by 40. That's it. That's what the point estimate is. Did you do a point estimate that's a standard deviation? Sample standard deviation? Yes. Sample variance? Yes. The mean is the most unbiased point of estimate. So that's one we're going to use today. All right? Okay. Confidence interval. And this is the big thing. So your point of estimate, your mean, very rarely will your number be dead on that when you take your sample means. Okay? It's not going to be exactly that. But we're going to build a confidence level where it's going to be within an interval of a low or high. Okay, so that's what we're going to talk about today, how to find this confidence interval and predict. Okay? So the point estimate is the middle guy, so that would be your sample mean, and you're going to add and subtract what we call a margin of error to find your upper limit and your lower limit. All right. So the level of confidence is the probability that the interval estimate contains the population parameter, whether it's mean or standard deviation or variance, whatever you're talking about, assuming that the estimation process is repeated at a large number of times. So again, this is your true value estimating. As long as the mean is in between this confidence level, you're going to be okay. That's an example of 95. So 95% of the time when you predict, your estimation should be within that confidence level. All right? And again, it's all going to be done with formulas. All right, so the level of confidence is the area under the standard normal curve between the critical values. So we're going to find the critical values. That's what you have to be able to do. So this is your level of confidence, this blue area. So the tails are things that aren't going to be in your interval. So find ZC, which is your confidence, at 85%. What you want to do is you want to take 1, the whole area, minus 85%. There's 15% in the tails. Between this tail and this tail is 15%. So what percent is in this tail? 7.5%, right? And there's 7.5% in this tail. So if I want to find this z-score, it would be 100 minus 7.5%. Does that make sense? And this z-score is just going to be, we don't need to worry about the negative, though. We just want this guy. This is what we're going to use in the formula. So if you take 1 minus the confidence level, split that in half, and then do 1 minus that number. That's going to be your Z sub C. Okay, your critical value. And again, that's a Z score, so we're going to be using that chart, the standard normal curve chart here. Okay. So no matter what percentage they give you, this is what you're going to have to do to find it, to find your Z score for the chart. So get your charts out. We haven't found the Z score yet. Find 0.925. We want that area. 0.925. What's the Z score closest to if it's not smack dab in the middle? I see it as 1.44. So again, you're going in this middle and finding 92.5%, 0.925. The closest one is 0.9251, right? So that would be your confidence critical value. Now, we don't have to do this over and over and over again. You can, but the ones we're going to use most often are these. So I would write those down so you have them handy. And that's doing the same thing. The tail area is 0.05. So you would go to 0.95. Bless you. So these are the ones you would find on your Z score. Those are the numbers that the area that you find, and then you can find the Z scores. So you can double check me. 0.95 is right in between 1.64 and 1.65, so that's why they split it. 0.975 is dead on 1.96. 0.995 is between 2 again. So that's why it's a 3-digit Z-score. Okay. So be able to do that by hand, but these are the ones we're going to use most often, probably on the homework, okay, or on a test. So if you have them memorized, that's great. If you don't, they're not hard to find. Okay. Here we go. The margin of error. So we're finding, so we have that point estimate in the middle. We're finding what are we going to add and subtract to that to find our levels. Okay? So you're going to take that Z-score from your confidence level and you're going to multiply it by the sample, the standard deviation of the sample means. Okay? And we did the standard deviation of the sample means last chapter. If you remember, it's the standard deviation divided by the square root of the sample size. So I would write it both ways so you can remember how you're finding it. But the standard deviation of the sample means is the standard deviation of the population divided by the square root of the sample size. This only works, remember, from last chapter, when the sample is random and the population is normally distributed, or n is greater than or equal to 30. So those are kind of stipulations. This formula works. This works only if the population is normally distributed or n is greater than or equal to 30. Okay? So that's the margin of error. That's what we're going to add to the mean and subtract to find our low and high of the interval. So again, none of it's really going to be complicated. You just have to remember when you have to do what. All right, here we go. For a random sample of 64 dates, The mean record high daily temperature in the Chicago area has a mean of 84.13. Assume the population standard deviation is 14.56. Find the margin of error using a 90% confidence level. So we're going to do the error equals z sub c times the standard deviation over the square root of the sample. Okay? What is z sub c? What's the z-score that corresponds to 90% confidence level? You wrote it down, yes? 1.645 times the standard deviation of the population is 14.56 divided by the square root of the sample size, which is 64. So it's not hard. You're just plugging in some numbers here. So I get 2.9939. Is that what we all got? So 95% are going to be within that, plus or minus that, of that point estimate that we found. Okay? Yep. All right, so the confidence interval, and this is just, we're doing step by step, guys. You're going to find that error, and you're going to add or subtract it from the sample mean. Okay? So remember, in the box, this is just the standard deviation of the sampling distribution. The larger this gets, the smaller your interval, because you're going to be dividing by a larger number. So the bigger the sample size, the smaller that margin of error is going to be. Okay? We said the z-value is determined by the confidence level and your standard normal chart. Okay, so understand what all those symbols mean. Because I think that's the most confusing thing is when you're looking at your formula sheet and you have no idea what the x with a line over it means. Right? Or the z with the sub c, what does that mean? So know what all these things mean. So here are your guidelines. First thing you want to know is verify that your standard deviation is known. If it's not, we're going to go on to next chapter or next section. Okay? The sample is random and either the population is normally distributed or n is greater than or equal to 30. If these things are there, then you can continue with this formula. Find the sample statistics n, which hopefully they're going to give you, and the sample mean. If you don't have it, if they give you a table of numbers, you have to find that sample mean. Find the critical value z sub c that corresponds to the given level of confidence. And again, we're going to use this formula, or the formula in this little chart. If it's not one of the three we're going to have memorized. Find the margin of error, and then you're going to add or subtract it from the mean, the sample mean. Okay, so let's see if we can do one. From a random sample of 36 business days from February 24th, 2016 to February 24th, 2017, the mean closing price, so they're giving you the mean of a sample, is 116.16. What's your n? Equals 36. My n's greater than or equal to 30, so I can use this formula. Okay? The population standard deviation is 10.27. Construct a 95% confidence interval for the population mean. So, we have to figure out our margin of error with these numbers. What is our z sub c? 1.96, because it's 95%, yes? Standard deviation is 10.27 divided by the square root of n. We just wrote that as 6. So what do we get there? Use your calculators. So we are sitting at 116.16. We are going to go this way by adding 3.35. We're going to go this way by subtracting 3.35. And they may have you write it as an interval. Okay? This is the low limit, high limit. So 95% of those sample means should fall within that. Okay? That's not really hard, is it? We're all good? It's just step-by-step learning all the little pieces? Okay. Determining the sample size. Because we have all passed algebra 2. Get the n by itself. Solve for n. Take a minute, do your algebra steps, and get n by itself. If I cross multiply, I have this, yes? Then we're going to divide by e, and I get this. And then how do I get rid of the square root? Square both sides. So n equals z sub c times standard deviation over the error, margin of error, squared. Right? And that's just simple algebra. It's not like they create a whole new formula. They just rewrote the old formula in terms of n. Okay? So on your formula sheet, it's just going to have this. Now we have a little, C and R's or whatever. It's the same thing. Okay? And again, this is when standard deviation is known. But all we did was rewrite the formula in terms of n. Okay? So don't let that be, there's nothing, no magical thing there. So, determine the minimum sample size n needed to estimate the mean for the given values of C, standard deviation, and error. So, we have what? N equals Z sub C times standard deviation divided by E squared. We need to figure out what Z sub C is of that. Figure it out. 1 minus 0.8 is 0.2. So both tails total 0.2 together. So what's the top tail? 0.1. So 1 minus 0.1 is 0.90. Look at our chart. Find the area, or the z-score that corresponds with the area 0.90. Yeah, 1.28. Okay? So 1.28 times 4.1 divided by 2, and I'm going to square that. I get 6.88. This is a sample size, so what should you always do? Round up. Go to the next whole number. Okay? Jen? All right. That's it.